Ladies and gentlemen, welcome to this screencast in which I am going to introduce you to the concept of convexity. I am going to assume that the viewer already has an understanding about the bond's duration and its application in estimating the interest rate risk. What I'm going to do is that in this video we are going to just look at the concept of convexity, and as we go on to subsequent videos we are also going to derive the formula for convexity and use it for our calculations. For now, what we want to do is to look at this graph here, which is showing us the relationship between two variables. Number one, percentage change in the price of the bond, which we are measuring on the y-axis here, and number two, percentage change in the YTM, which we are measuring on the x-axis here. This P is our starting price, my friends, and this Y is the corresponding yield. Now, because yield and price are inversely related, you can see that as the yield falls from Y to Y minus, the price of the bond increases. This PD plus, that is this point on this line, is the price predicted by the duration rule, and this P plus and the corresponding point on this curved line here is the actual price that obtains in the market. Conversely, if the yield rises from Y to Y plus, the price of the bond should fall, and this PD minus here is the price predicted by the duration rule, and this P minus here is the actual price. Obviously, what you observe is that there is a pricing error. Also, my friends, you see two lines in this graph. One of them is a straight line, this one here. It is sloping downwards and it indicates the percentage change in the bond price as per the duration rule. Please keep in mind that the straight line which plots the duration rule implies that the percentage change in price is directly proportional to the percentage change in yield. In other words, you could also say that according to the duration rule, the relationship between the bond price and yield is a linear one. Now let us focus our attention to the curved line here, which is convex in shape. Now this is the actual plot of the percentage price change in response to a change in the yield. And at once we can see that in reality we may not have a linear relationship between the bond price and yield as indicated by the duration rule. So in reality this relationship is convex. That is why you have this curved line. Also, please note that at the initial yield y, both these lines, the straight line and the curved line, both these lines are tangent. Also, in the near vicinity here in this area, if you look carefully, these two lines remain pretty close to each other for small changes in the yield. It tells us that the duration rule is a fairly okay estimation of the price yield relationship in case of small changes in the yield. But you can see as the change in yield gets larger, both lines go their separate ways. You can see there is a lot of daylight between these two lines here and at this place as well. This simply tells us, my friends, that for large changes in yield, the duration rule deviates from reality because the reality is not linear, it is convex. Now let us clean up this graph a little bit. Let us get rid of this straight downward sloping line, and let us only have in the graph the curved line which is convex in shape. What you should observe from this second graph here is that we are allowing the yield to change towards the negative side by a given amount, this amount here, and then we are going to allow the yield to change to the positive side by the same magnitude, same amount, and then we are going to study how the price of the bond is responding to these changes in yield. Let us first of all look at when the yield falls from Y to Y minus, this amount of change in the yield towards the negative direction, and what you observe is that in response the price of the bond increases from P to P plus, and this is the change in the price of the bond, an upward change in the price of the bond. On the other hand, if you allow the yield to increase by the same amount as you allowed it to decrease, then also there is going to be a change in the price of the bond. It's naturally going to fall, but this time observe that the fall in the price of the bond, this region here, is not as much as you saw here. So what you observe is that for a decrease in the bond's yield from Y to Y minus, there is a increase in the bond price to the amount that is greater in size than the corresponding fall in the bond's price here that would occur if there were an equal sized increase in the bond's yield. And this happens, my friends, due to the curvature in the price yield relationship. This curvature is called convexity, and as an investor I like it because if I have my money invested in a bond, I stand to gain more through a fall in the yield than I stand to lose in case the yield rises by the same magnitude. Ladies and gentlemen, I'm going to stop here for now. When we meet next time, we are going to continue this discussion and we are going to go on to the derivation of the formula for convexity. For now, it's bye-bye. Take care and have fun.